Good afternoon. It is Wednesday, the 10th of February, and here are the answers for the factors pairs worksheet. Now, today I'm actually going to go through all of the answers because I think the maths is now beginning to get a little bit more challenging. So some of you might want that little bit of extra help and reassurance. So let us start with question number 1. Alex is making arrays using counters. We all know what arrays are now. What calculation is represented in each array? So if we look at our first array, we have got one row of 18 counters. So we have 1 times 18. In our second array, we have got 2 rows. And each row contains 9 counters. So we have 2 times 9, which equals 18. In our third picture, we have 3 rows of 6. So we have 3 times 6 equals 18. So what we've got to do is use our answers to help write all the factors of 18. So if we go back, we have 1 and 18 is a factor of 18. So 1 times 18 makes 18. 2 times 9 also makes 18, which means that 2 and 9 are factors of 18. And 3 and 6 also make 18, which means 3 and 6 are also factors of 18. So our answers are going to be 1, 2, 3, 6, 9, and 18. Let's move on. Use counters to make arrays and find the factor pairs for each numbers. Right, I'm not going to go into all of these for you. I'll show you how to do number 12, and then I'll give you the answers for the other ones. So for 12, we always, I've got the number 12, and we can always multiply it by itself, 1 by itself. So 1 times 12 equals 12. And 1 and the number itself is always a factor. So all numbers have at least 2 factors, which would be 1 and themselves. Okay, and if I wanted to draw that array, I would do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I'm now going to go to number 2. I like to do things in a system. So I'm going to say 2 times something. Is there another number that I can multiply 2 by to make 12? You're right, it's 6. 2 times 6 is 12. So I'm going to have 2 rows of 6 counters. And there you go. Now I'm going to try out number 3. 3 times something equals 12. 3 times 4. So 3 times 4 equals 12. So I'm going to go 1, 2, 3 rows of 4. I could, of course, do 4 rows of 3 because of the law of commutativity. But there you go, I have got 12. Are there any more? No. So if I was going to go look at number 4, can I multiply 4 by anything to make 12? Yes, I can multiply it by 3, but we've already got that. 5, no. 6, I can multiply it by 2, but we've already got that. So then we're repeating ourselves. So the factors of 12 are 1, 2, 3, 4, 6, and 12. The others I'm not going to go into in detail, but I'll just show you quickly. For 15, you can have 1 times 5. So you have the factors 1 and 5. But you can also, sorry, 1 times 15, but you can also have 3 times 5. So you've also got the factor 3 as well. Okay, and 15. So you've got 1, 5, 3, and 15. 24, you've got 1 times 24, so there's 2 factors. 2 times 12, there's 2 factors. 3 times 8, there's 2 factors. 4 times 6, there's 2 factors. Notice the pattern. If you start from 1 when you're trying to find your factor pairs, and go find any factor pairs that I've got 1 in, any that I've got 2, any that I've got 3, 4, 5, and so on, you're less likely to make mistakes. Okay. question 3, we've got to complete our little book here. Okay, so I know that all numbers have got 2 factors at least, 1 and themselves. So what other numbers can I multiply together to make 45? 2. 2 times anything. Can that make 45? No. Let's move on to 3. Oh, yes. 3 times 15 makes 45. 4. Is 4 a factor of 45? Is there a number I can multiply by 4 to make 45? No. Let's move on to 5. Oh, yeah. 5 times 9. 6? No. 7? No. 8? No. 9? Oh, yes. 9 times 5. But look, I've already got that. So I've gone through a system to help me find all my factor pairs. Let's have a look at this one, which is 64. So we've got 1 and 64. So we can have 2 and 32, 4 and 16. But we can also have another one here. What could that be? Anyone spotted something? That's right. 64 is a squared number. 8 times 8 equals 64. So you've just got a factor of 8 sitting there all by itself. Okay, so number 4 says find all the factor pairs for the number 72. So I am going to show you how I would do this my way. I would start by writing the number 72 here. And over at the side, I'm going to start with 1. 1 times what to make 72? The answer is 72. Then I'm going to look at the next one, 2. Yes, 2 times 36 makes 72. 3. Yeah, 3 times 24 makes 72. 4, that's right. 4 times 18 makes 72. 5. Oh, hold on a minute. There isn't a number that I can multiply by 5 to make 72. So 5 is not a factor of 72. Let's try 6. That's right. 6 times 12 is 72. Let's try 7. Oh, no, 7 isn't a factor. 8. Yep. 8 times 9. 10. No. And I think I've reached the end of my factors of 72. So we should have 1, 72, 2, 36. So yeah, 3, 24, 4, 18, 6, and 12, and 8, and 9. Let's move on. Okay, so are these statements true or false? Let's have a go. 8 and 2 are both factors of 10. Well, hold on a minute. 2 is a factor of 10 because I know that 2 times 5 equals 10. But is there any number I can multiply 8 by to make 10? No, there isn't, so it must be false. 5 and 50 are both factors of 50. Okay, so 1 times 50 equals 50. So yes, 50 is a factor. And 5 times 10 equals 50. So yes, 5 is a factor. So that one must be true. 25 has only 3 factors. Oh, let's have a look. I'm going to do this down here. So 25. So obviously it's got 1 and it's got 25. 2 times anything make 25? No. 3? No. 4? No. 5? Oh, look at that. It's a squared number again. 5 times 5 equals 25. But because it's a squared number, we're only going to take that factor once. We've got 1, 25, and 5. So the answer is true. And all the factors of 50 are odd. Well, the only way we can do this and work out if this is true or false is by doing it. So 15 got factors of 1 and 15. 2 and anything? No. 3 times 5. 4 and anything? No. 5 times 3, and so on. So basically, yes, it's true. All the factors are factors. There we go. Hope you're doing well. This is a bit tricky, which is why I'm going through all of the questions for you today. Right, number 6. The bigger the number, the more factor pairs it has. Use examples to show that Dexter is wrong. Okay, so he's wrong. We know what he's saying here is not correct, but we've got to prove it. So he says the bigger the number, the more factor pairs it has. So I'm just going to choose 2 numbers. I'm going to choose the number 4 and work out how many factor pairs it has. I'm going to choose number 5. So obviously 5 is bigger than 4. So let's do the factor pairs for 4. I've got 1 times 4. I've got 2 times 2. Okay, so I've got 3 factors. Okay, so let's have a look at number 5. So number 5 has got 1 and 5 and no other factors whatsoever. So that's only got 2 factors. So Dexter is saying that the bigger the number, the more factor pairs it has. So he's saying that 5 should have more factor pairs than 4, but that isn't right. So he's wrong. There you go. Dexter, you're wrong. Okay, let's move on. Tommy now. Tommy is finding factors of 12 and 18. 12 and 18 have the same number of factor pairs. Is he correct? Explain your answer. Okay, so what we need to do is we need to work it out. You can't explain an answer unless you work it out. So let's start with 12. Here's the number 12. So 12 has got 1 times 12, 2 times 6, 3 times 4. Then you would go on to 4 times 3, but we've already done that. So that has got 1, 2, 3 factors per pair. So 3 factor pairs for 12. Right, and now I'm going to change my pen colour and I'm going to find all the factor pairs for 18. So 18 has got 1 times 18, 2 times 9, 3 times 6, and then you go 4, no, 5, 6, then you go back to 6 times 3. So that has also got 3 factor pairs. So is Tommy correct? Yes. And we have just proven it. We've to explain your answer. You can say they both have 3 factor pairs. And now the next question says find 2 other numbers with the same number of factor pairs. Now I'm going to do this one very quickly for you, and I'm going to use the answers it's given you on the mark sheet because this is what we call trial and error. You just have to pick some numbers and see and work out how many factor pairs there are. If I get the number 32, as you have on your answer sheet, you've got 1 times 32, you have 2 times 16, and you have 4 times 8. So 32 has 3 factor pairs. Okay, and then the other number is 50. So I'll do that one for you. 50 is 1 times 50, so that's 1 factor pair. 5 times 10, which is another factor pair, and 2 times 25, which is another factor pair. And this is why it's getting very tricky now, because you have to do a lot of trial and error to find your answer. Okay, so question 8. Are you ready? Class 4B is having a sports day. There were 36 children in the class. I'm going to underline that key information. The children need to be in equal groups. What sizes are possible? So basically what we need to do is split 36 into equal groups. So we're basically finding factor pairs. Let's go for it. Here's 36. Wow, I can definitely have one group of 36. So I could have one huge group of 36. I could also have two groups of 18. Because 2 times 18 is 36. I could also have 3 groups of 12. Because 3 times 12 is 36. I could also have 4 groups of 9. Because 4 times 9 is 36. I could also have 6 groups of 6. Because 36 is one of those squared numbers again. 6 times 6 equals 36. So I can have all sorts of different sized groups. Okay, we are now going on to our very last question. Oh, are you feeling worn out? I am. Okay, Rosie is investigating factor pairs. Oh, this is a tricky one, really tricky one. She says 6 is a perfect number because when you add its factors together apart from itself, they equal 6. What is the next perfect number after 6? Now, this took me a bit of time to figure out. So I'm just going to work out why 6 is called a perfect number. So 6 is a perfect number because all of its factors pairs add up to 6 apart from itself. So here's 6. Let's find the factor pairs first. We've got 1 times 6 and 2 times 3. So that's one factor pair and that's one factor pair. So it says if I add up all of the factors, they should make equal 6 apart from itself. So let's cross out 6. So does 1 add 2 add 3 equal 6? Yes, it does. And then what you're asked is to find the next perfect number after 6. Now, well done if you've got this right, because it is really tricky. The answer sheet has told us that it should be 28. So what I'm going to do is show you why 28 is a perfect number. And you might then be able to go and find the next perfect number after that. And if you do, you will get lots of bonus dojo points. Are you ready? So 28 has got the two factors of 1 times 28. Okay. 2 times 14. 3 times nothing. 4, no. Yeah, 4 times 7. 4 times 7. And then that's it. Those are all the factor pairs for 28. So let's take off 28. It's gone. And I've got 1, add 2, add 14, add 1, add 2, add 14, add 4, add 7. So that makes 3. And then 14 add 3 is 17. Then 17 add 4 is 21. And then 21 add 7 is 28. Wow, it works. That's a perfect number. So if you can take the challenge to find the next perfect number after 28, you will get 5 bonus dojo. Well done, everybody. You've done really well. Your next maths lesson now is on Friday, and that lesson is called efficient multiplication. Bye for now.